You know those simple dials you see everywhere? On tire inflators, on boilers, on all sorts of industrial equipment? Well, those are pressure gauges. And today, we're going to crack open the mystery of how these brilliantly simple mechanical devices actually work. So, how do you measure a force you can't even see? I mean, that's what pressure is, right? An invisible push. But it turns out the answer is in some really clever old-school mechanical engineering that translates that invisible force into a number you can actually read on a dial. All right, let's dive right in. We're going to take a little journey here, starting with the heavy hitters, the gauges built for really high pressure, and then we'll work our way all the way down to the super sensitive instruments that can pick up on the tiniest little changes. Okay, first up we have the absolute workhorse of the pressure world. This is probably the most common mechanical gauge you will ever lay your eyes on, the Borden tube. It is, without a doubt, the king of high-pressure measurement. So what exactly is this thing? Well, believe it or not, at its core, it's really just a C-shaped metal tube that's been flattened a bit. It's sealed on one end and has an opening on the other for the pressure to come in. That's it. Its sheer simplicity is what makes it so incredibly tough and reliable. So here's the magic. How does it work? It's just so clever. When pressure from a gas or a liquid enters that C-shaped tube, it tries to straighten the tube out. It just wants to uncurl itself. Now, that movement at the tip is tiny, but it's connected to a set of links and gears that magnify that motion and make the pointer sweep across the dial. It's all mechanical, no electronics, just pure genius. And honestly, if you want the perfect analogy, this is it. Think about a type of party horn, the kind that unrolls when you blow into it. The Borden tube works on the exact same principle. The pressure just makes it want to uncurl. It's just a way more precise and durable version of that. And because it's so robust, you find this thing everywhere in heavy industry. We're talking steam boilers, giant air compressors, powerful hydraulic systems. Basically, anywhere you've got seriously high pressure that has to be monitored, chances are there's a Borden tube on the job. But, high pressure is just one part of the story. What happens when you're not dealing with those massive forces? What if you need to measure something much more delicate? Well, for that, we need a whole different approach. Enter the gauges that use sensitive surfaces. So meet the diaphragm gauge. Instead of a rigid C-shaped tube, this one uses a thin, flexible disc called a diaphragm to sense the pressure. And because it's so flexible, it's way more sensitive to small changes. The idea here is really simple. It's called deflection. Pressure pushes on one side of that flexible plate, and it causes it to bulge outwards. And just like with the Borden tube, that tiny physical movement is connected to a linkage that moves the pointer on the dial so you can get a reading. And here's another really great way to visualize it. Just picture blowing into a thin plastic bag. You see how it swells up and moves? That's precisely what a diaphragm is doing. The more pressure, the more it flexes. It's simple, elegant, and really effective. Okay, but what if even that isn't sensitive enough? What if you need to measure really low pressures, like in gas lines or even vacuums? Well, it's pretty clever. You just double down on the diaphragm idea. You take two of them, weld them together around the edges, and create this little sealed pod or capsule. This makes it super duper sensitive. So here's the key takeaway. A single diaphragm is great for low pressure. But when you put two of them together to form a capsule, you get a much larger surface area that moves more, which makes the whole thing sensitive enough for very low pressure situations. It's a simple change, but it makes a world of difference.
All right, on to our final type of gauge. This one works on a principle that you might recognize, maybe from a musical instrument. Let's talk about the bellows gauge.
Yeah, take a look at that. The heart of this thing is essentially a metal accordion. It's this thin, corrugated tube that's specifically designed to be able to expand and contract really easily. And this device is called a bellows gauge. It's perfectly designed for that low to medium pressure range, using that flexible, accordion-like movement to measure changes. And how it works is probably the most intuitive one of all. It's just an expansion principle. Pressure goes into the bellows, and the whole thing just stretches out. It gets longer. When the pressure drops, a spring helps it contract back. This simple back and forth movement is super easy to connect to a pointer to get a reading. That accordion analogy is really the best way to get it. If you've ever seen one being played, you know exactly how this gauge works. You squeeze it, the air pressure builds, and it moves. It's that same simple, reliable idea at work. So we've looked at three totally different, really cool mechanical principles, right? We've got the uncurling tube, the flexing plate, and the expanding accordion. So the big question is, how do you know which gauge to use for what? Well, this little chart sums it all up perfectly. For really high pressures, you need the tough guy, the bored-in tube, our party horn. For low pressures, you need something more sensitive, like the diaphragm, the plastic bag. For very low pressures, you need the even more sensitive capsule. And for that sweet spot, in the low to medium range, you've got the bellows, our little accordion. It always comes down to using the right tool for the job. So next time you're checking your tire pressure, or you see a gauge on a big piece of machinery, you'll actually know the simple, elegant principle that's taking away inside. These amazing little devices are literally all around us, silently turning invisible forces into numbers we can trust. Now the only question is, where are you going to spot one next?